Okay, so today we are going to be looking at factoring binomials of higher degree. So this term binomials, so bi, like bicycle, means two, right? So it's two terms. So for example, like an x squared plus 5. I have two terms separated by an addition or subtraction symbol. I can have like a 2x minus 7. It just has two terms, okay? So we're going to learn how to factor binomials today, okay? For prior knowledge, I changed what's on your paper because that's basically what the lesson is today, so I wanted to take that out. Instead, I want you guys to multiply the following binomials, but I'd like you guys to do this on the whiteboard that's under your desk. Okay, so remember to multiply. You take the first term and then you distribute. X times x and x times a positive 2. And then you're going to take the second term and you're going to do it again. Take the negative 2 and distribute. This is prior knowledge, so go ahead and just try this on the whiteboard. You're going to distribute and then combine my terms and see what you get at the end. All right, double check with your partner really quick. What did you guys get? Oh, double check with people around here. Can I have a partner? Okay, so all right. So walking around, some of you got it, some of you struggled a little bit. So let's talk about it. If I take the x and I distribute, x times x is going to give us an x squared, right? And then x times 2 is going to give us a positive 2x. And then with the negative 2 times x, that's going to be a negative 2x. And then negative 2 times 2 is going to be negative 4. And if I add those together, I get an x squared. And then what happens to the middle term? They cancel. 2 minus 2 is 0, so you don't even write it out. They just cancel and then bring down that negative 4. So you just get x squared minus 4. Okay? Go ahead and try the second one. Since some of you struggled, go ahead and try this one now. So same thing, takes first the x term and distribute it. And then take the second term, that negative 3. Oops, that was my highlighter. Take that negative 3 and distribute it. right, go ahead and double check with people around you. All right, show me in 3, 2, 1. For the most part, I think everybody got it, except for I think one person just multiplied slightly wrong here. So what's x times x? That should give you x squared. And 3 times x should give you a positive 3x. And then negative 3 times x gives you a negative 3x. And negative 3 times positive 3, that should be negative 9. I saw somebody with a negative 6, but 3 times 3 is 9. Again, bring down the x squared. The x's cancel because 3 minus 3 is 0. And then you're left with minus 9. So both of those two examples are pretty similar. I want you guys to take a look at what happened in each example. Like what happened to the middle term in both examples. And what do you notice is in common between the setup? Like, what do these have in common with these over here? And what happens to the middle term in both examples? So go ahead, and if you're sitting on the left side, you're a lefty. So lefty, tell your partner what happened to the middle term, and then what do they have in common in the setup? Okay, ready? So what did you guys notice? What happened to the middle term in both cases?
Got canceled out.
They both got canceled, right? Positive 2x minus 3x, it got canceled. Positive 3x minus 3x, those got canceled. What did you guys see in the setup of both examples? What did they have in common? Anybody? No? Thank you.
Well, they're both like multiplications, and both of them have an x and then
A number?
like a number on both things.
Exactly the same, right? X and 2, x and 2, x and 3, x and 2, right? But what's the difference then between like this one and this one?
They're negative and positive.
One's negative and one's positive, right? So anytime you have something that looks like that, where the first term and the second term are the same, and the only thing they have that's different is the sign, that is called the difference of two squares. Well, the setup is not called the difference of two squares, but these two right here, x squared minus 4 and x squared minus 9, those are called a difference of two squares. Okay? And then I'll show you a little bit more of an example, but maybe under the prior knowledge on your notes where it says like x squared minus 25, you guys can jot this down. Take some notes for yourself. A difference of two squares okay, and I will abbreviate this to dots. So D-O-T-S, difference of two squares. That happens when you subtract two squares. They will factor out into the same terms, separated by addition and subtraction symbol. Okay? So the difference of two squares is like when you have an a squared minus a b squared. You are subtracting two perfect squares. You will end up factoring them into an a minus b times an a plus b. Okay? That's our not rule, but basically that's how it works, okay? A difference of two squares, if you are subtracting two perfect squares, you can factor them into an a minus b and an a plus b, okay? So let's look at some examples. If I have an x squared minus 9, we just saw this in reverse. We multiplied it and we got x squared minus 9, right? But I can split this into the square root of x squared gives us x, and the square root of 9 gives us 3. And one would be subtraction, one would be addition, okay? That is a difference of two squares. You can split it into two binomials that are pretty much the same except for the addition and subtraction sign. So let's say I got x squared minus 25. That is a difference because it's subtracting. And x squared is a perfect square and 25 is a perfect square. So I can split this into the square roots. So square root of x squared, again, is going to give you x. The square root of 25 is what? 5. And then you need a subtraction and an addition symbol, okay? So those are called a difference of two squares. Very important, a difference means subtraction. There has to be a subtraction sign in between them, okay? And then these two have to be perfect squares in order for you to be able to split them up into two binomials like that, okay? I don't know if you guys remember all your perfect squares. So there's the multiplication table in the very front of your booklets. So if you look over to your multiplication table, if you see all of those diagonal numbers, those are your perfect squares. Your perfect squares are all of the diagonal terms. So 1, 4, 9, 16, 25, 36, 49, 64, and so forth. Those are all of the perfect squares between 1 and 20. So if I want to know what 9 squared is, well, 9 squared is going to be 81. If I want to know the square root, like what is the square root of 121? We'll look at the top. Number is 11 times 11. So the square root of 121 is 11. If I need the square root of 49, what's the square root of 49? 7. Good. What if I ask you what's 12 squared? 144. Okay, that's how you read the table. For the perfect squares, is all the diagonal ones there. Okay. So the common ones, usually you want to know the first 10. Those are the most common ones that show up the most. But occasionally you might get some of the bigger ones. Something else I want to review with you guys is the GCF. We will have to look at GCFs today as well. So back to your whiteboards. Can you guys tell me, well, do you guys remember what GCF stands for? Greatest common factor. So between 3, 9, and 12, what is the GCF? The factor. So what can you take out that they all have in common? Not multiple, but factor. So on your whiteboards, write the GCF here. What do they all have in common that you can divide out on the whiteboard? I'll look for one that works. Who asked me for one? All right, on your whiteboard, show me in 3, 2, 1. The GCF is 3 here. Why is it 3? Well, I can divide by 3 from all of those. 3 divided by 3 is 1. 9 divided by 3 is 3. 12 divided by 3 is 4, right? I can factor out a 3 from all 3 of those. All right, what if we have variables, though? What's the GCF from variables? See, I don't know if you've ever seen this before or not, but out of all 3 of those, what's the biggest thing I can divide out of them that they have in common? What do they have in common that I can divide by? On your whiteboards? I see some blank whiteboards, so double check with people around you. If you don't have an answer, check with people around you. And show me in 3, 2, 1. Awesome. We have X in common. The biggest thing we can divide out of all of those would be an X. So your GCF is X. Awesome. So keeping that in mind now, let's combine both things, the GCFs and a difference of 2 squares, into our first example for today. The directions say to factor each binomial completely. If the binomial cannot be factored, we write prime. So if you look at your notes, is right next to the prior knowledge right there. You do have this on your paper. It's right next to the prior knowledge. We have 9x cubed minus 16x. And if we look at the steps over here on the side, it says to first factor out the GCF, if there is one. So that's step number 1. Look for the GCF. So between 9 and 16, look at the terms, just the coefficient. Do 9 and 16 have something in common? Does 3 go into 16? 3 times 6 is 18. 3 times 5 is 15. So 3 does not go into 16. 9 doesn't go into 16. So there's no GCF in the coefficient, but look at now the variables. X cubed and an X. Do those have a GCF? It would be an X, right? So my GCF would be an X. So I can divide by X to both terms and see what we have left over. So the 9, I can't divide, well, 9 divided by 1 is just 9. But look at the x cubed divided by x. Remember, you subtract the exponent. So 3 minus 1 is going to give us an x to the what power? Squared. And then x divided by x is going to be 1. So I'm just left with negative 16. That was my step number 1. Factor out the GCF. My GCF was x. Okay. Step number 2, it says if the binomial is a difference of 2 squares, factor it into 2 binomial factors and then repeat the step as needed. So the very first thing you want to check is, do you have a difference? Dots, the D in dots stands for difference, meaning a subtraction. Do I have a subtraction in between my 2 binomials there, or my binomial? That's a subtraction. So then I want to check, do I have 2 perfect squares? So look at your multiplication chart in the front if you don't know your perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, and so forth. So you want to check, are your 2 terms in that list? So I have the 9 and the 16. Are both of those on the list? Yeah. Yes. I have a 9 and a 16, and I have the x squared. That means I have a difference of two squares because both of them are perfect squares and I have a subtraction, okay? So I do have a difference of two squares, so I can split it into two binomial terms. So I can split this into two binomials and then bring down your GCF. So to split it into the two binomials, remember you're taking the square root of each term. So what's the square root of 9? 3. And the square root of x squared would just be x. Your square root and the squared cancel. So it's going to be 3x. And what's the square root of 16? 4 and 4. And then I'm going to put, one is going to be a subtraction, the other is an addition. So 3x minus 4, 3x plus 4. And it does not matter where you put the plus, where you put the minus, because it's multiplication. And then it says repeat this step as needed. So you want to check to see if you have any more squares. If you notice that x is inside the binomial, these do not have a square anymore. So I can't move on any further. I am finished. That is your final answer to this example. Okay, so step 2 was to split it into two binomials if it was a difference of two squares. All right, let's look at the next example. Please copy this example. This is not on your notes yet, so copy it. 3x cubed minus 27x. All right, remember your first step is to look for a GCF. So look at the 3 and the 27. Do those have a GCF? I can have a 3 in common. And what about the x cubed and the x? And the x. So my GCF is a 3x. So then I'm going to go divide by 3x to both terms. And what is a 3x cubed divided by 3x? Well, first of all, 3 divided by 3 gives us 1. And then at x cubed divided by x, you subtract the exponents. 3 minus 1 gives us 2, so that's an x squared. And then a negative 27 divided by 3 is going to give us a what? Negative 9. And x divided by x is 1, so it's just x squared minus 9. I'm trying to zoom out. Sorry. Okay, then step number 2 is to check for dots. Difference of two squares. Is that a difference? Do I have a subtraction? Yes. Do I have two squares? 1, 4, 9, 16, 25. Is 9 on the list? Yes. And the other one right here is basically a 1. 1 is there. So I have 1 and 9 are both on my list. So I can do step 2. I'm going to split that into two binomials. And I got to take the square root of each term. So the square root of x squared is what? X. So put an x in the first terms. And the square root of 9 is what? 3. And then what do I put in between them? A plus and a minus. So minus and plus. Again, it doesn't matter if you put the plus first and the minus second. It's the same because it's multiplication. And then check it. Can I keep going? Do I have any more squares? Like the x squareds? We don't have any more x squared, so we're finished. That is our final answer for the factorization. All right, let's look at the next example. Go ahead and copy this one down. 2x to the fourth minus an 18x squared. Okay, look at both terms, and then righties, tell your partner what is the GCF here. Oh, what the? Okay, volunteers? No, thank you. 2x squared. Good. 2 goes into 18. And then I have an x squared and an x to the fourth. The biggest thing I can take out of it is a 2, because that's the only thing they have in common, is a squared. Okay? So remember that you're going to divide each term by your GCF and see what you have left over. What's 2 divided by 2? 1. And x to the fourth divided by x squared? Squared, because we subtract them. 4 minus 2 is squared. Minus was 18 divided by 2? 9. 18 divided by 3 is 6, but 18 divided by 2 is 9. And then x squared divided by x squared is 1. So I'm just left with x squared minus 9. And then check again step 2 for your dots. Perfect squares are 1, 4, 9, 16, 25, and so forth. Do I have a difference of 2 squares? Do I have a difference? Is it subtracting? Yes. Do I have a perfect square on the list? Yes. 9 is on the list, so I do have a difference of 2 squares. So I'm going to have to split that into 2 binomials by taking the square root of each of those. Square root of x squared gives us square root of x squared gives us x, and square root of 9 is 3. And then a minus and a plus. Then check inside your binomials. Do you have any more x squareds? I don't have any more x squareds inside the binomial, so I am finished. All right. Next one. Go ahead and copy this one. X squared plus 36. Okay, lefties, tell your partner, do we have a GCF here? All right, what you guys say? Do I have a GCF? No GCF. So now let's look at, I shouldn't put an X. I don't want people to think the GCF is X. Step 2, we're looking for dots. Remember, what does the D stand for? Difference. Do I have a difference? No, this is an addition. That is not a difference. It doesn't matter that 36 is a perfect square. Because that's not a subtraction symbol, I do not have a difference of 2 squares. Okay? So in this case, I did not have a GCF. I do not have a difference of 2 squares. So I can't do anything here. That means that this is actually a prime binomial. I don't have a GCF. I don't have a difference of 2 squares. So then we say that this is prime. Okay. I talked about it, but I don't know if you guys got what I was saying. I don't know if you guys all paid attention. So before I move on, I want righties to tell your partner how come we did not split it into two binomials. What was wrong with this example? Why was it not a difference of two squares? Righties, go ahead and tell your partner. Again, my question is, how come this was not a difference of two squares? Why was that not a difference of two squares? Let me see what you guys said. Simran?
It's not a difference of two squares because it didn't have a GCF or dots.
Okay, well, that's why it's prime. But why is this not a difference of two squares? Nancy?
Because the 36 doesn't have an X.
Well, that would be why it's not a GCF. Aaron, can you help us out? Why is this not a difference of two squares? Thank you. This is an addition problem, not a subtraction problem, which is why it's not a difference of two squares. That's how come we couldn't split it into two binomials, okay? All right, thank you. Next example, go ahead and copy this one. 5x squared plus 20.
So the other one, if it had a GCF, would it still be prime?
No. If it has a GCF, then it's not prime because you took something out of it. But good question. Okay, 5x squared plus 20. Can I have, I think it's Lefty's turn now. Lefty, tell your partner, do we have a GCF? And if so, what is it? So it's not prime. Like, it's prime because they had no GCF. It doesn't have a GCF, so it's not prime. All right. On a count of three, can you guys tell me the GCF? Ready? In 3, 2, 1. 5. The GCF is 5. So if I take those, divide by 5 on each term, what do we have left over? 5 divided by 5 is 1. And I'm just left with x squared. And then 20 divided by 5 gives us what? A positive 4. And then check, do I have dots here?
No.
No, why not? Because of the addition symbol. Now, the question came up, two people asked me this question. Does that mean this is prime? No, why not? It had a GCF. Good job. If you take something out of it, then it's not prime. This is called, that's just a GCF. So then, therefore, it's not prime because you had a GCF. Okay? I took out of 5. So then it's not it's not prime because it had a GCF. Okay? Versus in this last example, I didn't even have a GCF and I didn't have a difference. So then it's prime. But this one I did have a GCF. So then it's not prime. Okay. This is a practice problem. So on your paper, you can copy this one. You guys are trying this one though. This is a practice problem. So remember, first you're looking for a GCF. And then you're checking for dots. All right, go ahead and double check with people around you. Okay, ready? All right, for my GCF here, Deb, can you tell us what is the GCF? 2x. Thank you. So if I take that and I divide by 2x, tell me what do I have left inside the binomial? Fatima?
We have x squared minus 49.
Minus 49. Good. Thank you. So 2 divided by 2 is 1, and x cubed divided by x to the first, subtract that exponent, gives you 2. And then negative 98 divided by 2 is negative 49, and x divided by x is just 1. Sorry. All right, then you want to check for, is this a difference of 2 squares? Yes? Good. So I can split this into the square roots. That's going to give me a 2x. What's the square root of x squared? X. And square root of 49? 7. And then we do a minus and a plus. And they don't have any more x squareds inside the binomial. So that's your final answer to that. Okay? Don't put your stuff away because I need to tell you what your homework is. So homework, do not cross out the ones I don't tell you. We're gonna finish this lesson tomorrow, but the homework for tonight, you guys wanna circle number 1, 3, 6, 7, 9, 11, and 15. I'll show you how to do the rest tomorrow, but for sure try tonight. Do those few problems. 3, 4, 5, 6, 7. Do those 7 problems for homework tonight. And then if you guys have questions, let me know tomorrow. But we'll finish off this lesson tomorrow. Sound good? All right. Thank you guys for being awesome. Go ahead and clean up your desk. And then go grab the sanitizer and the paper towels to wipe down the desk, please.